Okay, let's get going here. Let's do one of these. Okie dokie now. Recording, yep. Okay, so I've been saying things like classes and objects for a little while now. We're going to start using them and inferring what ways we can interact with any kind of object and what the difference between a class and an object is. Okay, big two questions. What are objects? What are classes? And then let's get started talking about what we do in C#. We're going to finish up, maybe if we have time, with structures in C#. There should be a mix of people who know what structures are. Some people only get them in 161. Some people get them in 160. A structure? Hands, yes. Structures, yes. Structures, no. Okay. All right. So we'll talk about structures. All right. So, classes and objects. The whole point of object-oriented design, modeling real-world things, widgets, nouns, with an object. So, representing some sort of an abstract concept as an advanced data type. We're not talking about a single int. You can't represent a bank with an int. What are all the things that make up a bank? Like a bank. Like you go deposit money into the bank. Money. Whose money? Nate's? Oh, names. The names of people. Sure. I was like, Nate's money? Who's Nate? Can I be friends with Nate? Nate has money? What else goes into a bank? In making a bank, yeah. Employees. Who works at the bank? That would sort of imply that there are some permissions. Some people can move money. Some people cannot. What else? Think about it. Yeah. ATMs. There are ways of dispensing monetary things, and you can deposit things. There are customers. Customers have what? Can a customer have what? An account at a bank? Yeah. Can a customer have more than one account? Yes. How many accounts can a customer have? Yeah. So would you rather use statically allocated arrays or dynamically allocated arrays? Dynamic, because you don't know how many. Anything usually that you can describe as a noun is a good candidate for an object or a class. A bicycle. How many different kinds of bicycles are there? Well, how do you tell the difference between two bicycles? What kind of wheels? Brand. How many gears? Color. If it's got the tassels on the handles, very important. Does it have a basket? Does it have... Yes, that's the point I'm making. Why are you under the table? Does it have pegs on the back? Does it have pegs on the front? Does it have a bell? Does it have a horn? All of these things are what we would call a property. Okay? We describe the status of an object using properties or internal variables. Now, what can you do with a bike? You can ride the bike. I guess you could sell it. Selling is more like what do you do with a bike object. But what about, can you ring the bell? Not if it has a horn. But you could make some kind of a noise. You could make noise. And then depending on what kind of bike you had, if it was a bell, it would go ding ding. If it had a horn, it would go honk honk. Any other kinds of... Can you do a wheelie? Sure. I think you're getting into the spirit of this with me. So any kind of verb, ride, ring, pedal, that's a method that would be associated with an object. So you've got an object contains a bunch of information about the noun, and then a bunch of verbs that it can do. How do we do this? Well, variables are going to be the status or the data associated, and then methods are going to be those behaviors. Any object is an instance of a class. So one class is like a blueprint, and an object is a actual implementation of that blueprint. With one blueprint for a house, you can build a whole development. Although in truth, you need like 4 or 5 different models to keep the locals happy, right? So the whole point is to represent something from the real world. And the reason we do that is because you can inspect something from the real world. This computer, what are the facts about this computer? Not that you can see it. Maybe you can. It's a yoga. So that's what? The brand is who makes it. Who makes yogas? Lenovo. The model would be a Yoga. I think this is a Yoga 4. There's probably a serial number. How big is the screen? I think we're agreeing somewhere between like 13 and 17. Somewhere in there. I think it's 15.6. Sure. Does it have a numpad? Nah, too short. You need a 17-inch to get the numpad. All right. So, let me ask you a question. Can I change the screen size? No, it is a fixed quantity. Things to keep in mind. Some things we can change. Some properties we can change. If I have a bank account, can I add more money to it? Can I subtract more money from it? To a point. Oh, all right, here it goes. Formal definition of a class. It acts as a template from which an instance of an object is created at runtime, meaning not at compile time, when you're running the program. A class defines the properties, screen size, and the methods, pedal, honk, used to control an object's behavior. Obviously, my laptop doesn't honk. I was going back to the bike. The bike honks. What does my computer do? Crash. I guess a bike and a computer do share some methods. Did I go the right way? Okay. If you want this, it's on the M-Drive. So, they provide a structure. They tell you all of the data items that are going to be a part of this object. And they define, so that's attributes. Depending on what kind of a noun that you're modeling, you might call that the object's state. Your account, if you have an account class, you can have a bank account, you can have a bank account, you can have a bank account, not you. Your bank account can have an amount of money. You can query that amount of money. You can withdraw. Withdraw is a verb. That's a method associated with that. That's your behaviors. Now, if my account balance is $123 and I try to withdraw $100, I should get $100, and how much should be left in my account? 123 minus 100 is $23. If I have $123 and I try to withdraw $200, what should happen? I should get $200 if I'm withdrawing it, but if you're withdrawing it, it should tell you to say, go to hell. How much should be left in your account after you attempt to withdraw $200? 123, whatever was there to begin with. All right, so when we talk about methods, these methods aren't like functions. Functions get arguments passed to them. When you call a method like withdraw, all you're giving that method is withdraw the amount you want. But because it's associated with a class and it's acting upon an instance of an object, I have to say it like that every time because that's the only way to make clear what's happening. An instance of the object. Okay, an object is an instance of a class. So the object has state. It has variables built inside of it that a method can actually query. So you just provide $200. You want to withdraw $200. But each object knows its own bank balance. Okay. So let's start talking about how we communicate with other engineers what the structure of a class is. This is a UML diagram. UML is a very, very large amount of specifications for how to communicate between engineers. It's called Unified Modeling Language. There are tons and tons of software things you can do with UML. We're barely going to be scratching the surface today with this box. This is a UML diagram for a single class. It's 3 boxes technically. The top box, account, that's the name of the class. And in C# we always start our class names with a capital letter. In the second box, you have any properties or variables that are going to be associated with that class. So, owner and amount. Now, nothing in there is there by accident. The plus has a special meaning. It means that anybody can call it. It's called public, but we don't know enough to talk about public versus private yet. The colon says whatever follows is the data type. So what is the data type of owner? It's a person. Person itself is a class. What might a person have as properties in their class? Properties are variables. Age. So we know how old the person is. A name. Yes. If this is a bank account, what might you also want? Social security number, a way to validate them. What about, how do you get in touch with them? No, that's not how banks do business. Use little... No, address, registered mail people, an address. But maybe a phone number, get in touch with them. Send them spam, call them when they're having dinner. Okay, these are the sorts of ideas that we're doing. We're building a model of a real world thing. Now, is a person going to contain eye color? Well, for a bank account, do you really need to know their eye color? No. Not really. I mean, maybe if it's getting it from some other database, it might have eye color already. Like the DMV, if this was a DMV record, you probably have eye color and whether or not they wear glasses and a few other things like that. But we're dealing with a limited model. We don't need to know your hair color, your date of, well, maybe your date of birth, but we don't need to know everything about you. We don't need to know your blood type for a bank account. We're trying to reduce the complexity by providing only what we need. So we've got 2 things. Amount, that's a double, because we want to store how much you have. Now, the operations or methods are the 3rd box. And in this case, we've got one method called suspend, which would suspend your account. It's a verb. We're going to suspend the account. Doesn't need any arguments. Deposit and withdraw, they take in one argument called the sum, the amount that you wish to withdraw or deposit, and it is also a double. This is UML. This is the order that you do it. The nice thing about UML is it's not C# specific. You do it in Java, you do it in C++, do it in Python, do it in R, I guess. That's your thing. It's agnostic of language. Okay, so an object is an instance. It actually takes up memory while you're running. So you can create many accounts. We can have Alice's account, Bob's account, Kathy's account, Dave's account, Enos's account. Okay? And there's some more vocabulary that we need to deal with. When you create an instance of a class, it's called instantiating that class. So, we've been using the new keyword a couple of times for things like arrays. We're instantiating an instance of an array. Objects have state. So in the case of this class, the account, it has 2 variables that contain the state of the object, the owner and how much money they have. Ivan's account, Peter's account. What we've got here is not strictly UML. On the left is the UML diagram for the class. On the right are 3 instances of that class. The variable name is in the top box, and then the state is in the second box. So, Ivan's account His owner is Ivan, and he's got about $5,000. Peter has got 18, 25, and 33 cents. Kirill, well, Kirill, where are you? Raise your hand. You're in my class, obviously. Yes. So let's get to actually C sharp here. Any questions so far on what these things are? Go back a little bit. Hey, go back. What happened? No, go back. Okay. Let's take a break here for a second. A class contains how much information, how much at runtime is allocated for a class? Enough bytes to store what? An object, whatever the object is. No. At runtime, a class stores no information. A class is just the blueprint. Doesn't store any information. An object allocates memory at runtime. So, if you have 50 classes or 100 classes, you allocate the same amount of memory. If you have one object versus 10 objects, that's going to be 10 times the amount of memory. Now, for a given object, it will allocate enough memory for each element in its properties. So if it has 5 integers as properties, it will allocate 5 integers worth of memory. Okay. Now, we've been using classes since day one because everything in C# has to be a class. It's just that we've been dealing with a special class that contains main, and that's where we start our execution. Okay. A class in C# can contain fields, that's information, it's variables. Properties are fields with logic around them, like your bank account. You probably want to make that a parent or a property because you don't want people withdrawing more than exists. Methods are the verbs that we operate on. Constructors are a special type of method. Is that a question or is that? That's fine. You do whatever you like. If you've got a question, I want to answer it. Constructors are a special kind of method. When I say that we instantiate an object, we are actually calling the constructor method. Constructor method sets up the initial state. Plus a bunch of other things that we're not going to talk about until we need to. Things like indexers to make arrays and operators to do operator overloading. We've been using a lot of classes. In the .NET framework, everything is actually a member of this system namespace. Console is a class, string is a class, int32 is a class, array, math, random. These are all classes. In C#, some of these things have shortcut names like int. Int is technically a system.int32, but the shorthand is int because that's what everybody likes to do, and if engineers are nothing if not lazy. Same with string. Technically, that is a class object int32 and a class object string. We just call them lowercase string and int. So declaring objects is the same as declaring ints. You declare them. But these have a little bit of a difference. If I declare an integer I and just truncate the line, say semicolon, what is the value of I? If I don't assign anything to it, null is not the correct answer. 0, because for an integer 32, the default value is a 0. This applies because an integer is a value type, meaning it does copies in memory, as opposed to a reference type. A reference type, if you assign things, doesn't actually copy over all the data inside the object. Anything that is a class or an instance of a class, an object, is a reference type. So when I create a date time called today, its default value as a reference type is null. So you got to keep in mind whether it's a value type or a reference type. And unless it's a value type, it's a reference type. The only value types are things like ints and strings. So before you initialize them, they are null. They don't point to anything. They are not a reference to anything. Okay. So fields. In C#, fields are a special name. They mean a variable, not a property. It's just a variable inside the class. When you access a field, no code gets executed except to change the value or access the value. This is accessing fields. So int32 is a class. Max value is a field in that class. Max value is 2 to the 31 minus 1. It's 2 billion and change. Positive 2 billion and change because that's the maximum value. No methods get executed as a result of accessing this. And it's the same with string.empty. Okay. Properties are a little different. Properties look like fields. They look the same way. You say something dot something, but they can have code associated with them. Things like error checking, bounds checking. Okay. They usually wrap some access to an inner data type, either a field, or you can make properties that have their own backing. In other languages, this is not built-in behavior. You have to create methods to get information, to query it, and to set information. And we call them getters and setters or accessors. But in C#, it's a built-in feature called a property. If you make a property, there is a get method and a set method. Depending on how you create these properties, you can make it so that you can only read, you can read, write, or you can only write. So you can do get and set, or only set. If you look at string.length, string.length is a property of the string class, and it's read-only. You cannot set the length of a string. Right? The length of a string is a function of how many characters are in the string. Would you agree? Okay. So here we go. Here we're going to use a new data type. The data type is a date time. So we create a date time object by saying date time Christmas. And we initialize it by calling the constructor for datetime. So the constructor is just always the name of the class. You say datetime and you provide arguments. In this case, the constructor for datetime takes a year, a month, and a day in that order. So this is going to create a date, Christmas 2009. With me so far? This data type has at least information about the year, the month, and the day. Probably, given that it's a date time, it also has information about the hour, the minute, and the second. With properties, we can access Christmas.day. Christmas is the object. Day is either the property or the field. And we'll be able to tell when we go into our demo which way it is. And I'll show you how to tell the difference. So by saying Christmas.day, we are accessing the day field of the Christmas object. Some of you may immediately pick up on how I'm saying this. Others of you, I'm going to keep saying until it goes home, because it requires that you tweak how your brain thinks about programming. Christmas is an object that has a whole bunch of functionality associated with it, as specified by the date time class. You with me? How many people are lost? They want me to slow back down on this. Where? Tell me. All right. Well, no, you explain it to me now, right? That's the best way. Use the right verbiage, and you'll always come out right. So, what is day? It's a field or a property. We can't tell. If it was a method, it would have parentheses after it. So we know it's a field or a property. So it's accessing some internal state about Christmas. In this case, it's accessing 25. That's the value of the day, field, or property. Okay? Everything else is pretty bog standard. Once we get them into integers, we print them out. Except the last line. The last line calls a method, is leap year. Anybody have that project in a previous class? Yes. Wasn't that fun? But you could just do this. The date time class defines how to create or determine if something is a leap year. Question? A what? Well, I wouldn't, but if it helps you right now, that's okay. If you open up a folder, it's got a bunch of pieces of paper in it. Each piece of paper across the top says what the field is called. Day, month, year. And then the rest of the paper is 25, 12, 2009. So you can have another folder that's Easter. And Easter changes every year, doesn't it? Let's do something else. Valentine's Day. Valentine's Day. Same 3 pieces of paper. Day, month, year. Instead of Christmas, it's Valentine's Day. So it's February 14th, 2020. Okay? I don't think I would stick with that because the analogy is going to break down. Because how do methods work in with your folder, right? So, is leap year, though, look at what's before is leap year. What's before the dot? It's not Christmas. It's date time. So there's 2 kinds of functionality. One kind of functionality is class functionality. The other kind of functionality is object functionality. So is leap year, you notice you don't give it a date time. You just give it a number, an integer. This is an example of a static method. A static method doesn't need an instance of the object. Okay? Think about that for a minute. A static method doesn't require an instance. So I don't have to create Christmas or Valentine's Day in order to figure out if a particular year is a leap year. I just use the date time class. So depending on what comes before the dot will tell you if that method is a static method or an instance method. All right, I've taken it away. If I say Christmas dot something, is that an instance method or a static method? I just said it. Let's go back. If it's class name dot something, it's a static method. I'll wait. If it is Christmas, Christmas is the name of an instance. So if it's an instance variable name dot something, that is an instance method. Okay. So let's do a couple of these. Okay. So here's Christmas Day. All right. I'm going to put a breakpoint right there and build it. This doesn't actually require any user input. It's just creating a date time object. Ooh, what did I just do? I just built it. Okay, properties and fields. Debug. When I debug this, what I want you to see is how we get the representation of a date time. Let it run. Here we are. Christmas shows up as a, well, maybe I can do it like this. Okay. Shows up as a little blue cube. See that? That is an indicator that that is a variable. Okay, that's how Visual Studio represents it. If you look at the value, notice it's a true date time. It's 12/25/2012 at 12 a.m. Where did the 12 a.m. come from? Well, if you look at the constructor, there's the constructor. Remember that we talked about methods that could have default arguments? Last class? Last class. If you look at this method, by the way, to get this, you do Control-Shift-Space, and it gives you a listing of the arguments. There are actually 12 different copies of this constructor. I don't know if I'm going to be able to do this. I can, yes. So version 6 takes a year, a month, a day, an hour, a minute, a second. So one can assume that the version that only takes a year, a month, and a day defaults the hour, the minute, and the second to midnight. Although, is midnight today or is it tomorrow? I guess in this case it's treating it like today. It's the first minute of today. But if you're awake at midnight, Santa's not going to bring you anything anyway, so I guess it doesn't really matter. So we can actually look inside of Christmas, and there is way more stuff in here. Let's go through what we've got. So we've got the day of week. Apparently it was a Tuesday. The hour, the kind. What kind of a date time it is. Millisecond, minute, month, second, ticks. Apparently that's how many ticks that is. Time of day, the year. Yep, there it is. There's the time of day. It's 000. Okay, now, what is the symbol next to all of these? Both of those answers are correct. Those are properties. A wrench means it's a property. Okay? Now, just like integer, which had max value, there are these things called static members. What does static mean again? No. It's part of the class. It's not part of the object. So these static members have nothing to do with Christmas. It's shared among all things of a date time. And what do we have here? We've got, actually, how do I, I think technically I need to do this. You can see that, right? So we've got the maximum value. What is the largest date time we can represent? I could not have said it better myself. Maybe next time I will. The earliest time is, I guess, the 5 days after the start of the AD era. January 1st, year 1. Jack Black was there, I think. We've also got some extra properties. Remember, the difference between a field and a property. By the way, the blue cube means field. The property can execute some code. So do you see that right now it's 4:39:58? Well, technically, where's my time? Technically it's 4:40. But when this was evaluated, it was 4:39. If I run one instruction, notice that now has changed. Oh, wait, no, I got to do it over here. Now has changed. It's now 4:41 and 41 seconds. I feel like I'm in a Spaceballs movie. When will then be now? Soon. Okay? Today looks like just the date, but starting at 12 o'clock, right? So a property can execute code every time it's accessed or modified, which is helpful in many ways. So all of these up here, these are properties. Why would you need seconds to be properties? We actually talked about this last class. We were talking about changing seconds when we talked about validating data. What's the valid value for the seconds field? 0 to 60 or 0 to 59, depending on who's asking. So we could go in to seconds, and we could type 59. Edit. Okay, we'll do it here. Commands. Command window. Christmas dot second equals 59. No, I want immediate. That's better. Christmas, yes, that's better. Christmas dot second equals 59. Look at what it says. Property second cannot be assigned to its read only. Okay. So we might ask ourselves, how do we change the seconds? Once we set it, are we stuck with it forever? Well, not really. If I type Christmas and then dot, see all the, wait, can you see all the purple? No, they're gone. See all of the, oh no, I gotta do it here. Okay. See all of the purple cubes? Those represent methods. So if I wanted to add seconds, nobody saw that. My hand was on. Excuse you. Wasn't mine, it was just there. We have to use the indefinite article a ass, not your ass. That would make you and let's add 10 seconds. All right. So here's an interesting thing. Okay. Look at our object. Our seconds, where are they? There they are. Our seconds are still 0. We added, what did we add? 10 seconds. Over here, our date time has changed. Right there it is, 12:10, or 12 o'clock and 10 seconds. Why hasn't the object changed? Well, we need to go one step deeper. Let's look at that. Let's look at that routine again. If I bring up the help on it. What is the? Oh, you can't see that. Let's let's do it up here. Stop. Christmas dot add seconds. Here we go. The method is datetime.addSeconds. Takes a double. Returns a new datetime that specifies the number of seconds. So you notice the return type there is datetime. It's a datetime object. This is taking an existing datetime object, creating a new one, adding 10 seconds to it, and giving you that new one. So you always have to be aware that when you're using objects, some will operate in place. They will modify their state. Others will take their current state, augment it, and return a new value. Christmas dot. Yeah, so there's is daylight savings time, subtract the local time, universal time. There's about 50 or so methods and properties here that we can access. But no, get rid of this, there are no fields that we can directly access. Unless we're talking about the static fields, which are not that interesting. All of the fields are protected. When you have a protected field, it's known as private. Now, in the debugger, you've got a few helpers here. You can actually view non-public members. It's sort of cheating. It's hide. It's peering behind the veil. So here is the only non-public field or non-public property. Internal ticks. That number is the only thing that gets stored. Everything else that you see is derived from that number. So I assume that this is taking from some sort of an epoch. Maybe it's September 1st, 1970, or January 1st, 1970, or I suppose it could be 2000, could be 1900, could be the start of, well, I suppose since the earliest date it can represent is January 1st, 0001, that maybe it's epoch, okay? But everything else is based on these ticks, which is how it's implemented. If you were to write your own date time class, you could provide the same interface, properties for day and month and year and time and hour and minute and second, and is it a leap year and is it in a leap year? You'd do all that, but you don't have to do it based on ticks. Do it based on whatever you want to. Okay? We are going to take the next couple of classes and continue talking about objects. And at some point, I swear GitHub Classroom is going to allow me to assign projects to you, and you can expect at least 2 to come out pretty quickly, like at the same time and be due the next day or something. I did record the GitHub lecture for today's class. I will post that. That will be to augment last year's GitHub. It's done using only the command line. And I actually cover a different project. So if you were in the Monday lab, I actually do a different project than the Friday lab. So feel free to go and watch that. It's about an hour. Any questions on what we've done so far, especially properties versus fields, classes versus objects, static versus instance? Great. All right, well, have a good weekend. You know, for someone who pays a lot of attention in class, I just spent like 3 minutes talking about when the homework would come out.